Okay, so now we are doing day 2 of your points of concurrency. So let's do some math with actually knowing where these things are located now. All right, so let's look at the circumcenter. So remember, the circumcenter is formed by your perpendicular bisectors. So let's go here. Let me make this a little thinner. All right. So it is formed by your perpendicular bisectors. So remember your perpendicular bisectors. You're going to find the midpoint, make sure you know they're equal on both sides, and then you draw a line that is perpendicular. Sometimes it will go through the corner, sometimes it may not. So just as long as you know the perpendicular bisectors. Remember that when you find the circumcenter, it's going to be equidistant to all of the vertices or all of the corners. So if I were to find the midpoint over here and I drew another perpendicular bisector, this point right here would be my circumcenter. So in this picture, it says that point P is the circumcenter. So this is the circumcenter. So it's perpendicular to all the edges at the midpoint. That means that all of these, if you go to the corners, those are all the same. So if this one's 13, then so is this one, and so is this one. So it says point P is the circumcenter of triangle ABC. Find the length of PA. So that would be 13. You have to know that it is equidistant to the corners from the circumcenter, okay? Now in this one, it says that point P is the circumcenter of triangle, and this should say EFD because our triangle is down here on the bottom. So if you want to make sure, I accidentally cut that off. That was not intended. All right, so if point P is the circumcenter, so notice it's an obtuse triangle, and remember an obtuse triangle, the circumcenter is outside. So that means the distance to all of my corners still follow the same rule. So if you were to draw this one, so that means all of these are going to be 10. So PE is 10. So all you got to do, find the circumcenter, draw a line to the corners of your triangle, and that is going to be the same length for all 3 parts. All right, let's look at the next one. Now we have the end center. Remember, the end center is formed by your angle bisectors. And this time, the end center is equidistant to the sides. So remember, if you have a triangle and you do an angle bisector, so those two are equal, and of course I'm just eyeballing this, it's not rocket science here. So that means this point right here, if I were to draw a line to each side, so draw a perpendicular line here, draw a perpendicular line here, and a perpendicular line here. In my picture, it is clearly not, it does not look to be true, but it is. But all of these have to be the same size. Obviously, if I did this correctly, it would be obvious that these were all the same length, but we're just going with the fact that I eyeballed this, so your circle is here, so that would be the radius of each one. All right, so let's look at this. It says N is the end center, so this is the end center. That means these 3 are equal because it's equidistant to the side. So ND, so that's this piece here, is 2x minus 5. And NE, which is this one here, is negative 2x plus 7. They want me to find the length of this one. So I'm going to have to find the length of these because it's going to be the same. So let's go through and let's do the math here. So we've got 2x minus 5 equals negative 2x plus 7. So if I add this 2x over here, I've got 4x minus 5 equals 7. Those canceled. I'm going to add this 5 over here. Now I've got 4x equals 12. And then divide both sides by 4. X is 3. So now that I know that x is 3, I can just plug it in. So ND, which is equal to 2x minus 5, x is 3, so that means 2 times 3 minus 5. 6 minus 5 is 1. So that means ND is 1, which means NE is 1, which means NF is also 1. So plug and chug. Find it and plug it in. The centroid. Now the centroid is located, oh, first of all, it's formed by your medians. Almost forgot that. So it is formed by our medians. And it is 2/3 of the distance. So if you go to the corner and you go to the centroid, this is 2/3. This bottom part is 1/3. Also, if whatever this is, whatever number, this one is always half. So if this is 2, this is 1. So that's why it is a 2-to-1 ratio. So if point P is my centroid, so point P is the centroid, and I'm going to erase these numbers here where we can use the ones that they gave us. It says if QN, so QN, so the whole thing is 33, find the top part. QPN, find the bottom part. QP. So I know that the top part, because it says it's 2/3, so the top part, PN, is 2/3 of the whole thing, which is 33. So that means PN is 2 times 33 is 66, and 66 divided by 3 is 22. So that means this part is 22. So this part, clearly I am struggling here today, 22. And that means this part is 11. My brain was thinking this is 11 and I wrote 11. So the bottom part or the smaller part is always half of the bigger part and 1/3 of the whole thing, however you want to look at it. Okay, and this one here, point D is the centroid. So if DE is 7, so that's the smaller part, so it's 7. So that means this part is 2 times bigger. So 2 times 7 is 14. So that makes this 14. So CD is 14, which means the whole thing, 7 plus 14, is 21. So the whole thing is 21. All right, and then our last one is our orthocenter, which is formed by the altitudes. And to be honest, there's not a lot of specialness about this one. It's just we're going to figure out if it's inside, outside, or on. But remember, if it's obtuse, it's going to be out. If it's an acute triangle, it's going to be in. And if it's a right triangle, it's on. And specifically, it's at the right angle. So that would be the orthocenter. Okay, so if it is a right triangle, it is on, because it's where the heights intersect. This is a height, this is a height. They intersect right there. So depending on where we lay this thing down will determine. So let's plot these points. So we have 3, 6. So 1, 2, 3, 1, 2, 3, 4, 5, 6. So there's my first point, X. 3, 0, 1, 2, 3, 0. And 11, 0. So 3, 4, 5, 6, 7, 8, 9, 10, 11. So draw your lines. And I have a vertical and a horizontal, so that means that's a right angle. So that means here is your orthocenter. Because it is a right triangle, therefore it is located at the right angle, and there's your answer. So when it's a right triangle, it makes it super duper easy. All right, so let's do some practice. So in exercise 1 and 2, P is the centroid, and it wants me to find PN and QP. So this is the centroid. So QN is this piece here. It's the whole thing, and it's 45. So that means PN, the top part or the bigger part, is 2/3 of the whole entire thing. So 2 times 45 is 90, and 90 divided by 3 is 30. So this is 30. The bottom part is half of 30, which is 15. So PQ is 15. You can always double check your math. If these add up to the whole thing, then you know you're good. So PN is 30 and QP is 15. Easy peasy. All right, the next one says QN. So again, the whole thing is 39. So 2/3 of 39. So 2 times 39 is 78. And then 78 divided by 3 is 26. So this part is 26. So that means QP is half of 26. So that makes it 13. And that's pretty much how simple it is. Obviously, there's going to be algebra involved. We're going to have to plug this in, but it still operates the same way. All right, now, if this is the centroid, again, DE is 12. So if DE, so now you know the smaller part, which means the bigger part is 2 times bigger. So to find CD, you're going to go 2 times 12. Well, that would be 24. So that marks 24 here. Now the whole thing is the big part plus the small part. So 12 plus 24 is 36. And that's how that works. Now, what about the algebra involved? So let's talk about it. So we know that BD is 4x plus 5. And BF, which is the whole entire thing, is 9x. So what I know is that the top part, BD, is 2/3 of the whole thing, BF. That's the rule, okay? So now take the information that's given, so BD, so 4x plus 5, is 2/3 of the whole thing, which is 9x. So 4x plus 5, so 2 times 9 is 18. 18 divided by 3 is 6. So now you just go through. So I'm going to subtract 4x. So I've got 5 equals 2x. Now we're going to divide by 2. So x is 2.5. So let's go up here, and it wants me to find the value of x, so we're done. We don't have to plug it back in or anything. So we just find x, so x is 2.5. All right, let's do it on this here. So now we're going to do this one. So I'm going to erase this part so that I have space to work. All right, so now let's do it in a different color where we don't get it mixed up. So now this part here is 2x minus 8, and GC, which is the whole thing, is 3x plus 3. So now we know the smaller part is 1/3 of the whole thing. So 2x minus 8 is 1/3 of the whole thing. And they were nice enough to give us 3s since we're working with a third. So we got 2x minus 8 equals 1 times 3 is 3. 3 divided by 3 is 1. 1 times 3 is 3. 3 divided by 3 is still 1. So we're going to subtract 1x. So x minus 8 equals 1, and then we're going to add 8. X is 9. So now we know that x is 9. All right, so just follow this part here. If you follow the general rule and plug in the pieces that they give you into the general rule, you'll be okay. Now, when we're asked to find the coordinates of the centroid, there's 2 ways. I'm going to show you the easy way, and you don't even need the grid, okay? So think about this for a second with me. If I have a line segment, okay, so I have 2 points. The midpoint is the middle of 2 points. Well, remember to do that, we add the 2 points together. So if we had 2, 4, and let's say this point was 6, 8. I would add them together. So 2, 4, and 6, 8. So if we added them together, that would be 12, 12, which means if I'm going halfway between them, then I need to take half. So that would be 6, 6. So this point is located at 6, 6. Well, if the midpoint is the middle of 2 points, the centroid is the middle of 3 points. So you do the exact same thing, but with 3 points. So we got -2, -1, plus 1, 8, plus 4, -1. So I'm going to add these together. So I've got 4 plus 1 is 5, and 5 minus 2 is 3. 8 minus 1 is 7. 7 minus 1 is 6. So now since I have 3 points, we're going to do 3. So 3 divided by 3 is 1. 6 divided by 3 is 2. And there is the centroid. Okay, so midpoint, add and divide by 2 because it's between 2 points. Centroid, you add and divide by 3 because it's the center of 3 points. Same exact concepts. You don't have to learn anything new. And that is it. So when you're done with this, you're going to get started on your assignment, and please ask questions as you're working. Bye.